Welcome to Integrals Applied Electronics Part 2. Example 1. If we apply a voltage V equals 90t raised to the 1/2 power to a circuit consisting of a 30 Henry inductor or inductance shunted by a 50 ohm resistance, what current flows when t equals 4 seconds? And we're going to assume that our I equals 0 when t equals 0. All right, so we're looking for, the question is what current? So we're looking for an IG, and IG is equal to V divided by R plus 1 divided by L times the integral of V dt. So we do some substitution here in the next line down. We've got 90t raised to the 1/2 divided by 50 plus the 1 divided by 30 Henries. 50 ohms for the other one, and our voltage, and then the integral of our voltage. So you can see, you can just stop the video if you want to and follow the math. Once you get it set up, the difference between this and the previous video is the current V divided by R is just a straight, we're not doing any integrals for that section, so it's just V divided by R is current. It's Ohm's law, right? The only integral is the V dt, which then becomes multiplied by the 1 over L. And our C equals 0 in this formula. We start with 0, and so you should end up with 19.6 amps when t equals 4 seconds. Okay, example number 2. In a parallel RL circuit, R equals 5 ohms and L equals 0.2 henries. If a voltage V equals t raised to the 3 seconds power plus 2 volts were applied, what would the current I be when t equals 4 seconds? Assume that I is equal to 0.4 amps when t equals 0. So now we're starting with the C. So we're going to include the 0.4 amps for C. Same formula as before. Ig is equal to V divided by R plus 1 divided by L times the integral of V dt. Again, you might need to stop the video and kind of go through the math. And just remember that instead of having 0 for C, this time we've got an I equal to 0.4 for our C, and you should end up with an Ig of 106.4 amps. Right, example 3, a current I equals 0.005 t raised to the 1/2 power amps flows in a parallel RC circuit where R equals 88 k ohms and C equals 1 microfarad. Find the formula for the voltage across the circuit as a function of time. Assume the capacitor to be initially discharged. So our VG, the formula that we're going to use is our VG equals R times I. There's the front end is just Ohm's law. Resistance times current is voltage. Now we're going to add that to a 1 over C times the integral of I dt. And we should get a final answer of VG is equal to 440 t raised to the 1/2 plus 3.333 times 10 to the 3rd power times t to the 3 seconds. And our C, we were initially discharged, so our C is equal to 0.